Hi, everyone. We're going to get started. Welcome to our webinar, 5 Steps for a Cost-Efficient Cloud Migration. This is brought to you by Logicworks and CloudHealth Technologies. I just wanted to get a few housekeeping details out of the way. Most of you probably used GoToWebinar before, but if you're having any technical issues or want to speak to an organizer, you can use the Questions tab on the lower right panel of your screen. One of our organizers will help you if you're having audio issues or you can't see the screen that we're sharing. There will be 10 or 15 minutes of Q&A at the end of the webinar, so if you have any questions for myself or Rachel from CloudHealth, please type those into the Questions tab on the lower right of your panel, and we will be sending out a copy of the webinar after the presentation. So let's go ahead and get started. Thanks everyone for joining us today. This is, again, 5 Steps to a Cost-Efficient Cloud Migration. My name is Steve Zeller. I'm the Vice President of Product Marketing here at Logicworks. If you're not familiar with us, Logicworks is a premier AWS partner. We also support Azure, and we have competencies across doing migrations, DevOps, healthcare, and security, and we're an approved cloud adoption delivery partner as well. I am here at our headquarters in New York. We also have offices in Philadelphia, Seattle, and Denver. And I am joined today by Rachel from CloudHealth. How you doing, Rachel?
I'm doing well. How about you, Steve?
Great, thanks. Do you want to introduce yourself?
Sure. So, hi, everyone. My name is Rachel Dines, and I run product marketing at CloudHealth Technologies. If you're not familiar with CloudHealth Technologies, we are a partner of Logicworks, and we're a fast-growing SaaS solution that helps some of the leading consumers of public cloud around the world get better visibility, optimization, and governance within their hybrid cloud environments. But we also help with a really key part, which is what we're going to be talking about today, which is planning for those migrations. So we also work very closely with AWS, but we also work with Microsoft, with Google, with VMware as well. And we've been growing very quickly around the world, and I'd love to work with our partners such as Logicworks. I'm based here in Boston, but we do also have offices around the world.
That's great. Thanks, Rachel. So let's go ahead and push on here. So the reason that we thought of this topic is that migration cost has been ranked as the biggest blocker to a successful cloud initiative. This is a study that CloudHealth actually commissioned from Forrester, and it shows the top 6 blockers to cloud initiatives. And you'll see that almost 38, half of the people marked migration cost as sort of the biggest reason that their previous cloud initiatives were not a success or were under expectations. So over the years, both Logicworks and CloudHealth have gained a lot of experience in doing cloud migrations, and so we put together these sort of 5 key points to try and help people get past this migration cost issue. So Logicworks has done hundreds of cloud migrations. We specialize in healthcare, financial services, and SaaS. And by following these practices, we've been able to help our clients to save an average of 40% on their migration costs. We help them to get to the cloud 3 times faster. And over the course of the whole cloud initiative, we're able to improve their return on investment by 30%. So these are really meaningful steps. We've tried to boil down many years of experience and hundreds of projects into some key facts that can help all of you out there in your cloud migration efforts. So what we're going to cover today, we're going to cover these 5 steps in detail, and they're all aligned with reducing costs in the different steps that are involved in a cloud migration. And these are applicable to Amazon Web Services, they're applicable to Microsoft Azure, and they're also applicable to hybrid clouds where you may be using your own data centers or traditional managed hosting equipment as well as a cloud provider. So the 5 steps that we've identified, you may have seen this before, it might sound familiar, but it's strategy, planning, building your cloud environment, migrating, and operating. And within each of these phases, we've identified some key best practices to help to reduce what we're calling the migration bubble, which is the delays and costs that can be associated with the migration process. So we're going to start with the first one, strategy. Strategy, I think a lot of companies see the word strategy and they kind of sigh and think it's a waste of time. In my personal experience, having a really coherent strategy is far and away the most important part of a cloud migration. At Logicworks, we use the cloud adoption framework to help our clients determine their strategy. This is a system that was developed by Amazon, but it is cloud agnostic, so it can be used to create a strategy for any destination cloud that you decide you might be moving towards. So it's a formal planning process, and what it does is it breaks down the cloud initiative into different areas like governance and business and people and operations. And we do this as a workshop. So we go in and we assemble a wide swath of different people in the company. And this includes a lot of the senior management team like the CEO, finance people, legal people, HR people that might be involved in hiring talent for cloud initiatives, operations people, and of course IT. And we go through a whole exercise. We have them write down their goals, their business goals for moving to the cloud, their risks, any questions they have, and we document this process right from the beginning with all the key stakeholders in the company. And the agenda for this goes through some different important areas like consolidating all these challenges, grouping them by the different stakeholders that are involved, identifying themes that bridge across the entire company, and then classifying these and trying to build a consensus around a 30 to 60-day plan for what actions a company can take to overcome and to achieve these goals, what priorities they have, what the next steps are. And when you walk out of this workshop, you have an action plan. There is a summary plan for the entire company, and then the top gets customized for each of these stakeholder groups. So legal might have an entire plan for them. HR might have a plan to implement hiring and training. Of course, the different areas of IT like networking and security and development and operations will all have plans for how they need to address the first 30 days before even starting to put hands on keyboards in the cloud. And what this does is it really does build consensus across the company. And again, it's easy to look at this and think that it's just kind of a waste of time to sit there in a committee and write things on Post-it notes. But we've really found that when it comes time to execute on the cloud strategy, having everything documented is extremely important and makes that next period go way smoother, and it has everybody aligned on the same page. So that's strategy. The next part is planning, coming up with a plan for your migration and documenting it. So the goals here are really to do an assessment of what you're running today, what is the current infrastructure, which application should I move first, what is my strategy for moving them, and who are the team members that are going to be required for this. And here at Logicworks, the reason that we're co-sponsoring this with CloudHealth is because CloudHealth has been an incredibly strong partner in helping us to do these assessments. And so I'm going to sort of pass the mic to Rachel. And Rachel, if you would kind of take us through CloudHealth's standard methodology for doing migration assessments, that would be terrific.
Yeah, absolutely. Thanks, Steve. So the planning phase, this is a really critical part, and this is where we work with our partners like Logicworks to help you plan out, all the things you need to know for the next phase, right? So you need to first understand and document your current infrastructure. This can be easier said than done, especially if you're in a large enterprise that's highly distributed. You might not have a centralized single system of record or CMDB that has exactly all of the infrastructure in all of your data centers or in all of your remote offices and who owns what. So that's one of the very first things that CloudHealth can help you with. I'll talk you through how this works technically, and I think this will also make sense as we go along. So we will connect agentlessly into your vCenter environment and start discovering all of the different configurations and all of the different assets in your environment. If you're not using vSphere, if you were bare metal or an OpenStack or something else, we can also use an agent-based approach for this. But either way, we're gathering all of the configurations, all of the performance, and all of the metadata about the infrastructure in your environment. Once we have all that data and we've been collecting it over time, we can start to group it into what we call perspectives. And these are basically logical lines of business grouping, so you can understand, all right, this application is consuming these resources, or this department is consuming those resources, and start to view your data center environment from a more business-centric point of view. Not only that, we can help customers assign on costs to what's running on premises. So you can really start to figure out, all right, this is how much this application costs me on-prem, and then start to analyze what this would cost in the cloud, which is what we do in the next phase. Next. So once we've collected all of the data about your on-premises environment, we can start to model out workloads for migration. So you obviously probably can't migrate all of your workloads all at once. So you would use those business level groupings that we defined in the previous step to decide, what am I going to migrate first? Maybe we'll talk in a minute about how you might decide what to migrate first, but you can look on an individual application by application basis and determine what I have, what the configuration is, but also very importantly, what the actual usage and performance is. So you might find that you've got highly underutilized infrastructure. In fact, we've found that a lot of our customers are only 10 to 20% utilized in the data center. Obviously, you don't want to take an underutilized infrastructure in the data center and then make it underutilized in the cloud as well. So we will make a right-sized recommendation for what you should move to from either AWS or Azure, and also let you know how much that will cost and what kind of savings you can expect to see. But of course, just understanding what you have and how much it would cost to migrate it is really only half the journey of the planning stage, because once you know the what, you need to determine the how. Next. So the how would be, what workloads I'm going to migrate in what order and what's the process I'm going to use. So a lot of people tend to think when it comes to migration that we need to do a big bang, get everything out of the data center at once. We hear all these, amazing stories about people migrating over 30 or 60 or 90 days. And while partners like Logicworks can definitely help you speed up migrations by a huge amount, it's definitely something you want to be very methodical and practical about what order you go about migrating. So we usually say, start with the easy stuff. Start with the workloads that have the least number of dependencies. Start with things that are wasting a lot of money, things that are really over provisioned. So, you might have used CloudHealth to identify, or worked with Logicworks and used CloudHealth to identify a certain application that's only 5% utilized. Maybe you want to start migrating that first. Another common approach is to start with the least critical workloads, right? So you're not just immediately migrating your mission critical production workload. So think about the order in which you go about this. And once again, these are all things, if this sounds like a little bit overwhelming, this is exactly what Logicworks will help you with. The other piece too is to understand the strategy that you're going to take. Once again, there's a common misconception that you need to take a big bang migration strategy, like we're going to lift and shift everything, or we're going to refactor everything. But the truth of the matter is you actually want to match the different workloads to the best migration strategy for each individual workload. So, you can see all the different arrows pointing here because, for some workloads, you might decide to do a lift and shift. So you're not going to change the application at all and just move it as is to the public cloud. You might determine that it's best to do either a partial refactor or a full refactor. This is probably one of the more common approaches for organizations that I've seen. Or lastly, maybe you decide you just want to get out of managing this application altogether. It's a commodity application and you're going to shift it to SaaS or PaaS. So a lot of these are really more strategic level decisions that you need to make as you're doing this migration planning. Next. And the last piece of the planning is to determine the architecture. So this is where you would work with Logicworks to determine what's the best architecture for you. I've really greatly oversimplified it here by just showing 4 different examples. But once again, these are the more common approaches that we've seen in our experience. So the first one is going from left to right, the hybrid cloud with workload separation. So this is where you locate workloads in different locations, whether it's public cloud, different public clouds, or the private cloud based on their business requirements. So, good example might be a very static or a legacy workload that you decide to leave on premises, but then a dynamic and bursty workload that goes to the public cloud. This is a very common approach. A little bit more advanced and a more complex approach, but is definitely starting to pick up steam, is this concept of workload balancing, where you would host a single application that can span both the public cloud and the data center, or across multiple public clouds. And so this might be deployed in like an active-active configuration with some load balancing. You might also use this for burstable capacity if you have, especially for retailers like around Black Friday, or if you have seasonal type workloads. This is a more complex architectural approach, but there's a lot of exciting benefits you can get out of this. The last two that I want to walk through is hybrid cloud for disaster recovery. So typically in this scenario, you'll have your data center continues to be your primary production data center, and then you turn your disaster recovery data center into the cloud. And this actually works really nicely because for most people, you don't need your disaster recovery data center on a day-to-day basis. You probably only need it the couple times a year that you test, and unfortunately, if you had a failure. So you can have a small amount of footprint running in the public cloud and then scale it up as needed as your disaster recovery site. And then the last option, this is really the simplest, is to just go all in. Say, we're going to shut down the data center and we're going to go all in on the public cloud. We're going to move everything over there, maybe over time. And this is probably also the least expensive approach and the easiest to manage. But for some people, they're not as comfortable with it. So I like to outline some of the different options that we typically see. Back to you, Steve.
Great, thanks, Rachel. So after we've used CloudHealth to do our assessment and our planning, we can move into our build phase, where we're actually configuring and spinning up that destination cloud environment. What we call this is our minimum viable cloud. So we usually like to start with just the bare essential networking and processing and platforms that are going to be required for your business to function effectively on the cloud. We also prepare applications for migration, and then we templatize that work to make it quicker to roll out services in the future. So this is where we can really start to implement these cost-saving measures. And the most important principle that Logicworks has uncovered is called this hub and spoke model of infrastructure. So typically when people arrive at Amazon or Azure, they just start building. So they spin up a VPC, a virtual private cloud network, and they put in security tools and access points and administrative tools and DevOps tools and start adding servers. And what that means is that when you start to build the next environment, you have to duplicate that work. So what you want to do instead is to, from the beginning, create this hub network. And inside that central hub network, you put any application or customer agnostic tools. And so these are security services, administrative tools, DevOps tools, access points, how you access the cloud securely, authentication, and all of the logging and administrative tools that you're going to use in the cloud. So if you consolidate all of those into your hub, then each spoke is just the servers and services that are specific to that workload or that client, and that's in a separate VPC. And then you start to build out multiple spokes that would form a circle around that hub network. And that way, you've already saved money because you've consolidated everything that does not need to be repeated in the center, and each piece that's in the spoke is actually required for a particular workload or client. This also helps with security because you've centralized your entire security model into this hub, and it's easily managed and administrated. What we do from here is we templatize this environment. And we do this using a few different tools. Some of the common ones are AWS CloudFormation or Azure Resource Manager. And in AWS, once you have multiple CloudFormation templates, you can organize those into AWS Service Catalog that allows you to spin up any of your CloudFormation library on demand. So the reason that we want to use these tools is a few things. It is consistency and reducing errors. So once you have a configuration that's templatized, each time you deploy it, you're eliminating a lot of manual work and room for error. You're also guaranteeing that all of the security and compliance checkboxes that you went through when you built it the first time are being repeated each time you deploy it. This also helps with tagging and naming conventions, which will become really important later when we talk about reporting. So each line of business, whether it's your ERP system or your research and development or your corporate website, should all be tagged and should all have consistent naming conventions for all the servers and services within that line of business. Also, templatizing really helps with time to market. So instead of having to then manually spin up this environment next time, using this template means our customers can spin up an entire new environment in a matter of minutes or hours rather than days or weeks. Um, and the templates cover a really deep amount of information. It's not just servers, it's servers and networking and security groups and identity and access management and different role configurations and services and things like encryption and security are all built into that. So this is a critical tool. I'm sure that a lot of you out there are already using things like this, but in terms of a basic cost saving measure, using templatization and DevOps and spinning up infrastructure makes a tremendous difference. So again, the template environment helps with a few goals. It allows you to spin up additional layers and additional networks very quickly. You've grouped all of your application agnostic tools into this management hub. And since you're using templates, you can take advantage of some of the cloud native features. So you can script an entire environment to go up and down when it's needed, like a disaster recovery environment or a development environment. You can script servers to add and remove themselves in response to traffic. And you can use platform as a service features like Amazon's managed database service or serverless technologies like Lambda. And there's also cloud native tools for security. Like at reInvent last week, Amazon just launched a machine learning intrusion detection service. So you'll be able to tap into new features like that directly from the cloud platforms. So that's a little bit our build. Now we're going to talk about the actual migration process, which is our fourth step in the chain here. So the migration process, and it really is customized. Some of our clients are migrating 20 or 30 servers. Some of our clients are migrating 2,000 servers. So the process can be tailored to the scope of the migration. But across all migrations, you want to identify the right tools. You want to get data to the cloud quickly. You want to maintain security through the migration process. And you want to reduce that migration bubble. So again, you want to have that migration happen quickly so you're not paying for two systems at the same time. And you want to enforce cost effectiveness from the beginning as a core motivation for the cloud migration. So the way that we found is most efficient to do this is through this concept of a migration factory. And so this can allow you to tackle a large number of servers in an agile format where you're doing sprints of certain groups of servers, and those can overlap, and you have a process for making sure that all the steps are followed across all these different groups of migration. So there's 5 steps to this. We talked about our application analysis, which we did using CloudHealth. So that analyzes, okay, what is the portfolio of applications? What are the resources? What are the inventories of hardware and operating systems and storage that those are running in their initial environment? Then we talked about our migration design, which is something that our senior engineering team will do. And then the actual migration. So there are, Rachel mentioned a few of the different types of migrations like lift and shift or refactoring. So lift and shift might use a software that automatically picks up servers at the block level and copies them over to the destination environment, tools like Cloud Endure or Adadata. Or if you're refactoring, this might be an engineering process where our senior engineers help you to reinstall applications on these platform services or in auto-scaling groups, etc. Then comes integration. So this is where we integrate our management tools into the destination environment. So the servers and the applications are there, and we're installing monitoring and security tools, backups and disaster recovery, management and secure access points, and reporting tools. And then finally, validation, which is destructive testing. So we want to see what happens when you lose a server, when you lose a load balancer, when you lose an entire VPC, or in some cases, when you lose an entire geographic region, and make sure that the system, comes back up and that everything is built according to the principles that we use. And this process repeats for each wave of servers. So we go from that minimum viable cloud, which is a kind of a proof of concept, and then we start migrating waves of production servers, and this might be client by client or application by application or workload by workload. But we want to make sure that we repeat this process for each wave of servers to make sure that we're doing this efficiently and eliminating error and making sure that everything follows the same process for consistency. And so now we get into our operate. And so this is really, Logicworks has over 20 years of experience helping companies to manage infrastructure. And there's a few different areas of this that we're going to cover today. And it really falls back on the same themes. We want to make sure that the cloud environment is efficient, that it's meeting those business goals that we talked about in the cloud adoption framework. And those goals continue over time. Just because you've built something right doesn't mean that your job is done. You still have to administer it and manage it and make sure that you're retaining that cost efficiency and that agility over time. And make sure that each team has clear responsibilities. So the development team has their role, the operations team has their role. As a service provider, we know what we're doing, and everybody's working synergistically together. So our clients will tell us that economically, it's just a little plug for Logicworks, working with a service provider is a lot more efficient than trying to hire up and train a team. That's why we're in business. So we have an entire team of people that can scale with the needs of a project. So the needs of a client at the beginning of the process of moving to the cloud are very high. Then once they're on the cloud, it becomes sporadic. They'll have an event like a product launch or maybe a security incident, and they'll need a lot of support, but they don't need to staff up a team to provide that support year-round. So they can leverage our engineers as they're needed, and it can scale up and down, which makes it a lot more affordable and a lot more efficient than having that entire team sitting there all year waiting for that type of event to happen. So we have a 24/7 NOC. You can open service tickets. You can escalate issues to our senior engineering team. We're monitoring for things like availability and security. As incidents come up, they automatically generate tickets with our team that we respond to. We also have a whole team working on DevOps automation. That's supplemented by our security and compliance team. As I said, we specialize in financial services and healthcare. So a lot of our clients have ongoing security and compliance concerns. They're going through audits. They're dealing with due diligence for various projects, and we help them with that. And then we do regular, well-architected reviews. That's another Amazon term, which means that every 6 months, or in some cases every quarter, we go back through the entire cloud environment and we take a look at where the customer's at. We want to make sure that all the best practices that we implemented during the build are still in place. And we also want to introduce them to some of the innovation that's going on. So Amazon launched over 2,000 new services already this year. And so we want to see if any of those services can benefit our clients. And of course, we want to help them with ongoing cost management. This is what a typical monitoring dashboard looks like at Logicworks. So we're going to tag every server for basic things like uptime and disk utilization and RAM and CPU performance. And then we're also going to work with our customers to embed more custom monitors that will look into their databases, into their applications, and make sure that just because the server's up and running, that doesn't mean necessarily that their content and their applications are performing. So we're going to make sure that the application layer is performing as well. And this integrates with our partners. So it integrates with CloudWatch, with our security services, and it automatically generates tickets from multiple systems that come back to our 24/7 operations. This is a little look at our DevOps process. Again, this is very simplified, but this is the type of system that we implement for clients, and there's a lot of value in automating almost everything you do. So at the blue vertical area is Logicworks, and the gray horizontal area represents a client. So you'll see that Logicworks came in, like we talked about through this webinar, and helped with building the system and migrating to it. And we put all of those best practices and tagging in place. Then we implemented these DevOps tools that you see on the left for the client's developers to use. So these are things like configuration management using a tool like Puppet. So that means that every time you spin up or bootstrap a server with an operating system and an image, you're doing that in an automated fashion, and you don't have to do that manually. When you implement your proprietary code, your application, you're using a CI/CD platform like Jenkins. And so you have a repository of all your code updates. You're able to deploy them, validate them, roll them back if necessary, and maintain a record of all of your code drops. And this allows our customers to, in some cases, do as many as a dozen code drops per day if they need to really keep up with product features and onboarding clients. And then they also might combine some of these and containerize an entire system using something like Docker or Elastic Container Service or Kubernetes, in which case they're deploying a container that contains code and servers and network settings and security, and they're dropping that directly into the production stack. Again, all of that means that their development group is never manually making any changes to the production environment. They can play around in the development environment, manually change things, but once they're in the production environment, they're using these DevOps tools every time to deploy automated workflows directly into production that are templated and can be rolled back and maintained. At the bottom there, you see all the data from the system is coming back to our management that I talked about in the last slide. So all the notifications and alerts and incidents are being managed by our 24/7 NOC. And then on the right, since we've tagged everything and we've implemented these tools, the system is speaking a common language with nomenclature and tagging, so it can be analyzed by some of our partner technologies. So these are things like performance data, security alerting. So the operations team at the client is able to pull up our central dashboard. We've consolidated these into Logicworks Pulse, which is our customer portal. So you can go to that and you can look at these different partner tools to make sure that the reporting coming out of the system is indicating that the system is meeting those business goals that you identified all the way back in that cloud adoption workshop. So you can look at each line of business. You can look at your corporate website for the security posture and what type of threats versus your very important patient portal or investment portal. And you can see those as two different entities and look at the performance of those and the security of those. And most importantly, you can look at the cost of those, and you can see how those are saving you money, how they're performing year to date or quarter to date, and then you can start to optimize them. And this is where we turn back to CloudHealth, because CloudHealth isn't just an important tool we use for doing assessments, but it's something that we offer to our clients throughout their relationship with Logicworks, and it allows them to continue to optimize cost all the way through the cloud process. So Rachel, I know I've been talking up a storm here, but if you're still with us, I'd love for you to take us through some of the ongoing cost management capabilities that CloudHealth offers.
Yeah, absolutely. Happy to. Yeah, so like Steve just said, ongoing optimization for cost is a really critical part of your operations once you're in the cloud. In fact, if you don't continuously optimize for cost, you'll probably run yourself into a little bit of trouble. So this is where we're helping a lot of customers. We work on cost, but also we can help you optimize for performance, for utilization, and even for security. But to focus in a little bit deeper on cost today, because this is something that really is very near and dear to my heart, and I'm sure to many of yours, is the first step in really understanding and controlling cost is gaining visibility. And visibility might seem like a simple thing, but really having cross-cloud visibility across all of your different accounts, all of your teams, departments, and being able to see that all in one place where you can compare it head to head and trend it and analyze it is actually pretty challenging. And this is what we provide to CloudHealth customers and Logicworks customers. So you can see here we're looking at our cost history report, which is trending over 13 months of data. And instead of looking at this by, server names or, AWS services, I'm actually looking at this by something that makes sense to my environment, which is owners. So this is one of the powerful parts of CloudHealth is no matter where you are within the platform, you can always be visualizing your cloud environment by whichever business groupings make sense to you, whether it's applications, owners, departments, teams, etc. So I've got visibility. Once I've got this visibility and I can trend it, I can look for anomalies. I can, set up alerts to notify me if there's anything unusual. The next step is actually finding opportunities to reduce cost. Next. And CloudHealth helps with this in a variety of areas, but one of the things that's really most popular is our reserved instance management capabilities. So we haven't talked too much about reserved instances so far in this presentation. This is a really critical part of reducing costs in both AWS and Azure, and Google has a version of these as well. And essentially, the concept behind reserved instances is giving your cloud provider a little bit of a heads up. You can, and purchasing vouchers or coupons for instances or for compute, you can get a pretty significant discount on your monthly bill. Now, I'm not going to spend too much time here going into all the ins and outs of the different types of reservations and how you might use them all because that would take much more time than we actually have today. But I did want to walk you through quickly how CloudHealth can help you purchase, manage, and optimize your reserved instances. So we can help you. We look at your environment, and you can set a budget and set a line of business that you want to purchase for, and we'll model out for you which are the best reserved instances that you should be buying. And this can be across all different classes, scopes, and types, from convertible to standard to all upfront to no upfront, regional to availability zone. If you're following along, there's a lot of different types of reserved instances, and we can help you model out which is the best choice for you, as well as how much each one of these is going to save you. So you can see here in this example on the right that we've done this analysis for a specific instance type, and we found that this is going to save us $10,000 a month by purchasing 99 reservations of a couple of different types. So once you've purchased your reservations, the next step is to make sure that they're continuously modified and up to date. So you've spent the money, you've committed the money, but now you need to make sure you're actually getting your investment, getting your return on investment. So once again, we can continuously monitor and even take action on your behalf, if you so choose, to keep your reserved instances always optimized and always applying to the most on-demand usage. Lastly, you need to make sure that you're staying on top of opportunities for new reservations, staying on top of expiring reservations, and in making sure that everything is running smoothly. And we can help, we can run that either via reports or policies. So everything from alerting you that you've got high on-demand usage and you could benefit from a reservation purchase, to you've got reservations that are expiring. It's time to start thinking about purchasing a new one. So there's really a very robust reserved instance management lifecycle here that we help with every component of it. And many of our customers can use these solutions to get up to high 90% of their EC2 instance hours covered by reservations, meaning they're very close to consuming AWS or Azure in the most optimal way they possibly can. So this is just a flavor of one way that we can help our customers and partners with optimizing. But I also wanted to share one additional approach. Next. So one of the other ways that you can save a significant amount of money is with this concept that we call rightsizing. What is rightsizing? Well, it's all in the name. You're trying to make sure that all of the infrastructure that you've provisioned is the right size for the workload. So let's say, for example, you have developers that even right after a migration, a right-sizing exercise can be really valuable. You look at all of the workloads that are running on your infrastructure, and you might see that they're really pretty underutilized. They might only be 10, 20, 30% utilized, and the rest of the time is waste. So right-sizing helps you look across CPU, memory, network, and disk, and make sure that you've actually picked the right instance type for the workload that you've chosen, because sometimes it can be very difficult upfront to predict this, or usage changes and drifts over time, and your workloads may become more or less performant and demanding of resources. So CloudHealth has a right-sizing report which can look at AWS EC2, AWS EBS, and Azure VMs, and tell you across all of these what how you're doing on from a score basis perspective across CPU, memory, network, and disk. Also, what you could be downgrading these instances or volumes to, if necessary, and how much you would save if you were to do it. So this can be a very, very significant cost savings as well, because as I'm sure you know, every time you downgrade from one EC2 size down to the next, like from a large to a medium or an extra large to a large, that cuts your costs in half. So this is a really powerful way to reduce your spend in AWS and in Azure as well.
Great. Thanks so much, Rachel. That's fantastic. And yeah, I have to agree. CloudHealth has been a real eye opener for a lot of our customers. We'll drop those reports in and see that a couple of really expensive instances are running at 5% of their capacity, and it can make a really meaningful difference in that customer's budget and the success of the project. So thank you. So that's all we have for the slides. We do have time for some questions. And I do have a question here from Bob in Vancouver. He says, how long does an average cloud migration usually take? Hi, Bob. So we split our migrations into sprints. So what we think it's important that you not do an all-in-one approach and you have more of an agile approach where you can move a subsection of servers. So just to go through those phases, I think that the most important thing is if you're going to work with a service provider or a consultant, the earlier the better. You know, start that relationship when you're in that strategy phase because they can help you to make the right choices early. So we like to start 30 days before the actual work happens, and that cloud adoption framework gives us a map for those first 30 days. The planning is really dependent on the scope, but usually takes 2 weeks for us to come up with that plan, run the assessment, do the CloudHealth work, and then make a recommendation, and then 2 weeks for the design. And then the migration itself is in these 2 week sprints. And we've found that once we've done that prep work, we can usually move anywhere from 20 to 40, 50 servers in one of these sprints. More if it's a large group of smaller servers that are automated and within sort of one pool doing one job. So I would budget time that way, and then I would always budget at least a month after you've completed it to do all of the final go live and testing and cutover, however you're finally doing that, like cutting over DNS or whatever your final step is. So I would say get started 30 days before you plan to do any of the work. Plan for another month of design and build. Plan 2 week sprints for each, let's say 20 to 50 servers, and then give yourself another month on the other end. I hope that's helpful. I had another question from Kim in New Jersey. She asks, I have to meet PCI compliance. Is there anything special I need to do during the migration process? That's a great question. Thanks, Kim. So yes, PCI, there's 4 levels of PCI depending on how many credit cards, the volume of dollars in credit card transactions that you do. You need to know which level you are at. Some of those, include a self-assessment. Some of those require an external audit. And in either of those situations, PCI has a number of different controls, and these range across encryption, how you're setting up your access and your authentication into the environment, third-party security tools like IDS and managing your logs and reporting evidence back to your auditors and that sort of thing. So that's a big question. It's one of our specialties here at Logicworks is we help financial services customers to achieve different types of compliance. Things like SEC applications or FINRA, different banking and investment applications, as well as your typical e-commerce and retail applications. So it's a deep question. Logicworks spends an awful lot of time every year running multiple audits, and what we do is sort of pre-equip the infrastructure to know that it's checked all the boxes and passes the audits, so that our customers only have to worry about their own business operations when they get into that. So if you want to contact somebody at Logicworks, we'd be happy to talk with you about how to achieve PCI compliance. But yes, there's a lot of detail around that, and you definitely need to be aware of that during the migration. We have another question from Mark. Hi, Mark. You mentioned Cloud Endure as a tool to migrate to the cloud. As for agent-based migration applications, do you prefer one over another? Any other agent-based applications you like? Great question. There's a lot of tools out there. We use a few different tools for analysis. CloudHealth is a great one, but to dive more deeply into specific infrastructure systems, we use tools like TSO Logic, Added Data, Risk Networks, things like that. Those are all good. Some of them are particularly good for VMware networks. Some of them are particularly good for bare metal servers. Some of them are particularly good for existing cloud accounts. It's really a case by case. And then for the actual migration, Cloud Endure has kind of risen to the top. Adidata also has a solid migration tool. There are a few others out there. Cloud Velox, I believe there's a few other ones. Cloud Endure we've found is pretty simple to use and pretty effective. The lift and shift migrations, as Rachel mentioned, are usually sort of one prong on the fork that we're using to move things over to the cloud. So there'll be a mix of refactoring, building out systems using cloud native tools, and also using lift and shift for um, larger groups of servers that are not going to be refactored. I would say that the most important thing for using any of these tools is that they work best for things that are sort of on current operating systems and sort of well-known technologies, Windows, Red Hat Linux, stuff like that. And so you may have to upgrade things in data center before being able to use one of these tools. We have not had as much success trying to use tools to do a lift and shift and an upgrade from an older operating system. That's been a little more troublesome. So I hope that's helpful. And then had one more question here. This was for Rachel. Can you talk about how you pull in and model on-premises costs in CloudHealth, and then how do you match them with AWS costs during the migration? So Rachel, maybe you can take that one.
Yeah, sure. That's a good question because I did mention briefly that part of the migration assessment, we show you your on-prem costs and compare them what it would be in the cloud. And you might be thinking, how the heck do you know my on-prem costs? I mean, so cloud costs are easier to consume, right? We pull in the billing records from your cloud provider. But in the data center, obviously that doesn't exist. So how do we do it? We have a couple of different approaches. The simplest way is, I mentioned earlier that we map and catalog all of your different configurations of infrastructure in your environment. So then we'll put them into like groups, and then you can either tell us in our calculator, which is like sort of a WYSIWYG cost editor, or via tags, how much those different configurations cost. So let's say, for example, we find that most of your VMs are running with 4 CPUs and 8 gigs of RAM and 2 terabytes of storage attached. You might say that configuration costs $10 a day. Or if you're less sure of what your costs are, we can even calculate this out on a more granular level. So we can use a benchmarked cost for this is how much a single CPU costs in the data center, and this is how much a single gig of RAM costs in the data center. And then use all of your configuration data to model out what that's actually been costing you over time. So it actually can be really powerful to use pre-migration as well to get a good feeling and good understanding of which lines of business and which applications are costing us the most, because you might determine that those, if they're less critical lines of business or less critical apps, those might be the first ones you want to get out of the data center. So then to do the mapping to the public cloud, we look at the actual consumption on the physical infrastructure or the virtual infrastructure in the data center. So we look at not only what's been configured and what's been allocated, but how much actually gets consumed on a daily basis for the workloads. We usually like to look at least a week's worth of data. That can give us a good amount. If you want to give us more data, we can make even more accurate analysis. We match up that on-prem usage data to the instances or VMs in the public cloud and tell you how much that exact workload would cost to run in the public cloud. So that's how we sort of do that apples-to-apples comparison.
Great, thanks, Rachel. We had one last question from Janet in San Diego. How much do customers usually save by migrating to the public cloud? Hi, Janet. Well, that's a tricky one. I'd say there's a few variables there. Of course, the first is how much are they paying now? So where are they coming from? Do they own and operate their own data center? Are they with a legacy data center provider, or is this a new application? Obviously, that's hard to predict. And then the other factor is which migration approach are they taking, right? Are they lifting and shifting servers, or are they refactoring? So to take those apart, lifting and shifting will really only save you money if your costs are high in your existing environment. So if you own servers and they're running there in your office, lifting and shifting them to Amazon or Azure is generally not going to save you costs. It might even cost a little bit more because obviously those vendors are purchasing servers and renting them back to you. So even though they have huge economies of scale and multi-tenancy and they're doing all these things to leverage that, at the end of the day, it's pretty cheap to own servers and have them there in your office running. Now, operationally, you may save a lot of money because you're having to patch those servers and update them and refresh the hardware and that sort of thing. But the actual migration, the value is less in a lift and shift than if you're actually able to refactor and take advantage of some of these tools that we talked about. So if you can actually refactor things, then all of a sudden an application that's only needed from 9 a.m. to 5 p.m. can be shut off at night. There's two-thirds of your cost right there. Um, Servers that are used for disaster recovery can be spun up when there's a disaster. That may be 100% of the cost of those servers right there if knock on wood, there is no disaster. Or a development or a testing environment that's only needed for a couple of months, that capacity can be added. So all of those are huge savings, but they really only can be leveraged on the refactor approach. But I don't want to leave the question without an answer, and I think in one of the early slides we did say that the average that we save is about 30%. And I'd say that's generally true across the board, although some of our customers can save 80% from where they were, and some of them may save 10%, really depending on the size and scope of that migration. So we're going to wrap up. I want to thank Rachel. Thank you so much for co-presenting with me today.
Yes,
And I
thank
want to
you for
thank all
having
of
me.
you. Absolutely. I want to thank all of you for coming. Once again, the webinar will be available offline. So that's it. Thanks very much and have a great day.